So they told us that the x's that they want us to think about are in the set of numbers from 0 to 5. So there's two ways to do this problem. Again, and we already said, and I had written on the board, that this is called the domain. That means even though there are more numbers that might work in this equation, we're only going to put down answers that are in this set. Because there are more numbers that work in this equation that we're getting on number 17. They're not all listed though, so that's why I wanted to have you think about this. We're going to go ahead and talk about how would I solve this, because this one is something you could probably do with stuff you already know. What is x times x? X squared. I could solve it like I'm solving an equation, and that's what we're going to do first, because that is the least painful way to do this. If you have something squared and it's equal to 1, how are you going to get rid of the square on the x to solve? How do you get rid of a square? You always ask yourself, what's the opposite of something? What's the opposite of squaring? What do you mean by cancel it out? You may be thinking the... Yeah, it's kind of like dividing them in half. What were you thinking? Square rooting. The opposite of squaring something is square rooting, right? So if I want to solve this, I say I got a square, and I want the x by itself, and it's got a square on it. The opposite of squaring is to square root both sides. So we're going to put a square root over both sides. Okay? So we always just ask ourselves, what's the opposite? And the opposite of squaring is square rooting. What do you think the opposite of cubing something would be? Cube rooting. We can cube root something. We can do all kinds of roots, okay? We can cube root something even. But we're squaring here, and you know a lot about squares. The square root of x squared is just what? X. Yeah, the square root of something is just that one thing back, right? Now, there's one thing I didn't write, and I'm going to write it now, and I'm going to put it in colors because I want you to know it. When I square root a number, and I'm solving, I always have to remember there's a positive root, square root, and there's a negative square root. Because aren't there two numbers? What is to square something? What does that mean? What did the original problem have you doing? Yeah, and it was multiplying x by itself. Aren't there? Now here's the other way you could have solved the problem. You could have taken each one of those numbers and multiplied it by itself and see which one equals 1. Which one would have worked? 1. 1 times 1 is 1. So we know the answer is 1 here if we just do one method, which is to try all these until we find what works. But that would get old if they didn't give us a short little list, right? And even if you're trying all those and to see which ones work, if you had to write them all down, wouldn't it be a pain? Because you'd have 6 things written down for every problem, which is why I first cut it to every other odd before I thought about what we were really doing here. So the only number in there that works is 1. Our answer is 1. But if I were working this out with algebra, I would also have to consider the fact that there is a positive root and a negative root, and the square root of 1 is 1, right? So really there are two answers to this problem. Positive one works and negative one works, except that did they list negative 1 up here for me to pick from? No, when they give you a domain, they're telling you only look at this list of numbers. Don't worry about anything that's not listed up there. Get what now? Sure. So the answer here is going to be 1, even though there are two things that would work if you solved it. So I kind of want to look at this from a lot of times a bigger perspective than the book. You could have plugged each number in to see what works, and that's fine. That's probably what the book wants you to do. But I want to go ahead and show you that you can solve without having to do that, and sometimes that's faster. So you could square root both sides. Just know that normally you would have to say the answer is plus 1 and minus 1 because 1 times 1 is 1, and negative 1 times negative 1 is also 1, right? Because two negatives make a positive. So that's something there to kind of think about. So number 25. It says 3 more than twice a number is 3. What's the number? Okay. What did they, if you got your book open, don't they give you a list of numbers? So I could solve this. I could write the equation out and solve it. And I'm going to do that because I really would rather y'all do it this way. But what's the other way you could work this problem? What else could you do since you've got this list of numbers? Like you're thinking of just a way to kind of keep up with what works and what doesn't?
What are you talking about?
On number 25, it says 3 more than twice the number is 7. What's the number? But the instructions for it are up at the top. It says solve each problem over the domain. And here they use that word, domain. These are what we're going to plug in. 0, 2, 4, 6, 8. Couldn't I plug each one of those numbers in couldn't I think about what to do? I could try to think about what to do and figure out the answer without solving an equation. Wouldn't it be easier if I had something written down that was a little more easier to understand than the words if I want to plug it in? Bless you. Let's kind of break this down a little bit. What does 3 more than mean?
Oh, that's what I was needing.
Plus 3.
Oh. Yeah, we're going to add 3 to something. When you see more than, I don't know if Miss Bailey told y'all this. I know I told my class last year. The word than kind of tells you in a word problem that some order is going to get switched. I'm going to add 3 to something. I don't know what it is yet. I could put 3 plus. That's not that it's wrong, but a lot of times you make less mistakes if you realize that when you say 3 more than, you're adding 3 to something. What are we going to add it to? Twice a number. What do y'all want to call the number? X? Let's use X because that's what we used to use. Okay, so 2X. Isn't twice a number 2 times the number? Couldn't we write it as 2X? And what's it going to be equal to? 7. Then what does is mean in a word problem? Do you remember? It means equal. Y'all knew it and you said it even without me asking. I just want to point it out. 7. Okay, now that I got that, it might be easier if I'm plugging in all those numbers to do it, but you know what? I'm kind of lazy and I don't like plugging in numbers like that. It gets really old. I just don't like it. So what I'm going to do is I'm going to solve it like with algebra, okay? And you can do either one. I don't care. I'd like for you to be able to, I'd like to see this. I want to see the equation written down even if you're plugging in numbers. I want to see what you're thinking in terms of math. Okay, so if I want X by itself, there it is. And I want to get it by itself, so what am I going to think? To solve. How do I solve? What do I think in my head?
-3, or do you have to do PEMDAS?
You're doing PEMDAS backwards, and you're doing PEMDAS backwards. When you solve, you always are doing PEMDAS backwards. So if you want to write it down, that's one way to kind of help yourself stay on track. I need to add or subtract anything first. I can't subtract the 2. It's not attached with addition, is it? It's attached with multiplication because they shoved it together. That's how we know, right? The only thing that's added or subtracted there is this 3. So when Luke said we're going to subtract 3, he's doing the opposite. Since we have a plus 3, we're going to subtract 3. We're going to always do adding or subtracting first, not the 2. The 2 is not joined with a plus or a minus. So that's 2x plus 0 is equal to 7 minus 3 is 4. But anything plus 0 is just itself, right? So what am I going to write on the next line? Am I going to write 2x plus 0? No. And a lot of times we don't even write the plus 0 the first time just because we know that. I just want to make sure we're emphasizing it. So 2x is 4.
And then divide 2 by both sides.
Yeah, and why did you divide both sides by 2? How did you know to do that? X is multiplied by 2. The opposite of multiplying x by 2 is dividing it by 2. And so the answer is x equal 2. So if you know how to solve, it's a whole lot easier than plugging all these numbers in to see how they work. By the way, what was the exponent on the x up here? Was there an exponent on it? There was an invisible one. It was an invisible one that the lazy math guy just did not want to write, did he? It's like, why should I write x to the first power? That's just x. You know what that one told me? Guess. There's only one answer, okay? So the exponents are kind of cool because they tell you how many answers to expect. Sometimes, it may be the same number 2 times, but here we only knew when I got one answer, I know I don't have to even worry about plugging any of those other numbers in because there wasn't a square on it. If there had been a cube on it, a little 3, I'd known there would have been 3 answers. Making sure I set my clock right. We're good. Okay. Okay, so let's go on to, let me turn that off. I could plug in all the numbers, 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9, because that's the domain they give me. That's the only numbers they care that I try to plug in. They don't want me doing anything else. And as a matter of fact, that's what I really think you should do here to work this problem. But y'all want to go ahead and see how you would solve it using the square stuff that we know? Okay, let me just go ahead and show you so that you see there is another way to do it, and maybe you'll start understanding why we want to do algebra. I don't want to, that's 10 numbers. If you count 0 through 9, isn't that 10 numbers to try to plug in? Isn't that gross? So solve the ones you can without plugging in all the numbers, and like on 35 and 37, if you don't know how to solve them, just plug numbers in, okay? But I'm not going to plug the numbers in. I'm going to go ahead and show you how to get it with algebra in case you want to start doing that now. 2f is what? Equal to f squared. Anytime you see a square or an exponent bigger than that, you've got to move all the numbers to one side and have 0 on the other side. That's what you always have to do. So what I'm going to do, because I don't want f squared to be negative, I'm going to move all my numbers over to that side, over there. If I want to move 2f to the other side, I can always add or subtract it. What will I do here? Well, it's a plus 2f, so I'll add a negative 2f, which is the same thing as subtracting a 2f. So I'm going to show you here, even though they're not expecting you to do what I'm doing, they're thinking you're going to plug each one of those numbers in. I just want to show you that if you can kind of get a hold of this, you can solve these this way. What's 2f minus 2f? 0. That's the whole reason I did it in the first place. I needed it on the other side, and I wanted a 0 on one side. Again, in math, anytime you have something bigger than, anytime you have a square or a cube or a fourth or a fifth exponent, you got to move everything to one side and have 0 on the other side, or you can't solve it. It's different than if it's what we've been doing, right? We don't normally do that. So we have f squared minus 2f. Now, I don't know if y'all remember, but some of the things you did last year are now going to start to make sense to you. You don't understand why you do things sometimes until you get to this point. Is there anything that divides into both f squared and 2f? Is there something you could divide out of it? F, right? F comes out of both of those. So if I want to take it out, I'm going to factor it. Factor it just means take stuff out. Again, would I ask you to do this on a test? Absolutely not. Okay, I'm just showing you a little bit ahead here. What's f squared? Divide a f out, what's left? Well, isn't f squared f times f, right? So wouldn't there be an f left, right? And then there's a subtraction sign, so I'm going to copy it out, down. F minus 2, because if you 2f and you divide the f out of it, you just have a 2 left. This is going to help me find my numbers faster. If you're one of those people who want to know how to do it faster, this is for you. Now think about this. If I have two things, here's one thing, isn't that one thing that's multiplied by another thing? Could they have written it like this? With parentheses? Sure. If they wanted to, they could have. They just, lazy mathematicians, don't put a parentheses if they don't have to. That's two things multiplied together that's equal to 0, right? So anytime you got two things multiplied together and they're equal to 0, what do you know? One of them has to be 0, right? I can't say 3 times 1 is 0. That's not true. It has to be 3 times 0 is 0. On the other hand, if I had some number times 7 is equal to 0, what does that first thing have to be? A 0, right? That's the cool, that's the only reason we can solve equations in math. That's the only reason we can, is because we know that two things multiplied together equals 0, one thing has to be 0. That's such a basic idea in math, it's bigger than you might have ever thought that it was. So either this is 0, which would mean f equals 0, but there's another possibility, isn't there? Because there's another thing that could have been 0, right? So I'm going to say, oh, it could have been that f minus 2 is equal to 0. And again, this is just the fast way to do it. I could have gone and plugged 0 in, then 1 in, then 2 in, then 3 and 4 and 5 and 6 and 7 and 8 and 9. You're going to have 10 problems with every problem to work, which stinks, right? Okay?